Article 400.7 of the National Electrical Code addresses the use of flexible cords and cables. It outlines specific situations where flexible cords and cables are permitted, as well as situations where they are prohibited. Based on the information provided, the installation appears to meet specific requirements of Article 400.7. Article 400.78 pertains to dry-type transformers installed indoors. It stipulates that these transformers must be accessible without the removal of any structural or finish materials. The planned installation seems to meet this requirement because the transformer will be accessible by removing the ceiling tiles. Article 400.17 addresses the enclosure of transformers. It states that transformers shall be enclosed to prevent accidental contact with live parts unless they are located in a room or enclosure accessible only to qualified persons. The installation meets this requirement because the transformer will be enclosed within the ceiling tile space, which is considered accessible only to qualified individuals. The use of a sealed transformer with a pass-through ground aligns with the requirements of Article 400.7. This section mandates that dry-type transformers installed indoors have a grounded metal enclosure. It is essential to consider a few additional factors. Firstly, ensure the transformer is properly secured and supported within the ceiling tile space. This prevents the transformer from shifting or falling, which could create a safety hazard. Secondly, the conduit running the 12 volts alternating current side of the transformer must be appropriately sized and installed according to Article 300 of the National Electrical Code. This article provides detailed guidelines for wiring methods and materials, ensuring the conduit system is safe and reliable. Thirdly, consider using a double insulated, also known as Class 2, power supply for the 12 volts alternating current load. This measure further reduces the risk of electric shock. Class 2 power supplies are designed with enhanced safety features, providing an extra layer of protection. Finally, it is highly recommended to obtain a permit and have the installation inspected by a qualified electrical inspector. This ensures compliance with all applicable codes and standards. Electrical inspectors are trained to identify potential hazards and verify that the installation meets safety requirements. Always consult the latest edition of the National Electrical Code and local amendments for the most up-to-date regulations. Proper planning, installation, and inspection are essential for ensuring a safe and compliant electrical system. Article 300 covers wiring methods and materials. Some of the key considerations within Article 300 that relate to running the 12 volts alternating current side of the transformer and conduit include firstly, conduit type. Select an appropriate type of conduit for the environment and application. Common types include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each type has different characteristics regarding strength, corrosion resistance, and flexibility. Secondly, conduit fill. Ensure that the conduit is not overfilled with conductors. The National Electrical Code specifies the maximum allowable fill percentage based on the number and size of conductors. Overfilling can lead to overheating and damage to the conductors. Thirdly, support and securing. Properly support and secure the conduit at appropriate intervals. This prevents sagging and damage to the conduit system. The National Electrical Code provides guidelines for support spacing based on conduit size and type. Fourthly, fittings and connectors. Use approved fittings and connectors for joining conduit sections and connecting conduit to enclosures. Ensure that fittings are properly tightened to maintain a secure and watertight connection. Fifthly, bending. If bending conduit, use approved bending tools and techniques to avoid damaging the conduit. The bending radius must comply with National Electrical Code requirements to prevent kinking or flattening of the conduit. Sixthly, grounding. Ground the conduit system in accordance with the National Electrical Code requirement. This provides a path for fault current to flow back to the source, helping to protect against electrical shock. Seventhly, protection. Protect the conduit from physical damage. If the conduit is exposed to potential impact or abrasion, consider using a more robust type of conduit or providing additional protection. Eighthly, labeling. Label the conduit to identify the circuits it contains. This helps with future maintenance and troubleshooting. Ninthly, accessibility. Ensure that the conduit is accessible for inspection and maintenance. Avoid running conduit in concealed locations where it cannot be easily accessed. Tenthly, workmanship. Install the conduit system in a neat and workmanlike manner. This promotes safety and reliability. Article 400.7 provides exceptions to the general rule that flexible cords and cables should not be used as a substitute for the fixed wiring of a structure. Understanding these exceptions is crucial for determining whether a particular application is permitted under the National Electrical Code. The exceptions are as follows. Firstly, pendants. Flexible cords are permitted for pendants. A pendant is a lighting fixture or other electrical device that is suspended from the ceiling or other overhead support by a flexible cord. Secondly, wiring of fixtures. Flexible cords are allowed for the wiring of fixtures where the fixture is designed to be moved or adjusted after installation. This exception recognizes that some fixtures, such as track lighting or adjustable spotlights, require flexible cords to allow for movement. Thirdly, connection of appliances. Flexible cords can be used for the connection of appliances where the appliance is designed to be easily moved or disconnected. This exception applies to appliances such as lamps, fans, and small kitchen appliances. Fourthly, elevators. Flexible cords are permitted for elevators and dumbwaiters. Elevators and dumbwaiters require flexible cords to connect the moving car to the fixed wiring of the building. Fifthly, cranes and hoists. Flexible cords are allowed for cranes and hoists. Cranes and hoists require flexible cords to provide power and control to the moving machinery. Sixthly, connection of portable equipment. Flexible cords can be used for the connection of portable equipment. Portable equipment is defined as equipment that is designed to be moved from one location to another. Examples of portable equipment include power tools, extension cords, and temporary lighting. Seventhly, data processing cables. Flexible cords are permitted for data processing cables as permitted by Article 645. Data processing cables are used to connect computers and other data processing equipment. Eighthly, connection of moving parts. Flexible cords are allowed for connection of moving parts. This exception applies to situations where a flexible connection is needed to accommodate movement, such as the connection between a motor and a driven machine. Ninthly, temporary wiring. Flexible cords can be used for temporary wiring as permitted by Article 590. Temporary wiring is wiring that is installed for a limited period of time, such as during construction or renovation. Tenthly, manufactured homes and recreational vehicles. Flexible cords are permitted in manufactured homes and recreational vehicles as permitted by Article 550 and Article 551. Article 550 and Article 551 provide specific requirements for the use of flexible cords in these types of structures. The 11th, connection of luminaires. Flexible cords are allowed for the connection of luminaires as permitted in 410.62. B and 410.140. D. These sections of the National Electrical Code provide specific requirements for the use of flexible cords to connect luminaires to the electrical system. It is important to note that even when one of these exceptions applies, there may still be specific requirements for the type of flexible cord that can be used, the length of the cord, and how it is installed. Always consult the National Electrical Code for complete information. Article 400.7 outlines specific situations where flexible cords and cables are permitted as a substitute for fixed wiring. It is crucial to understand these exceptions to ensure compliance with the National Electrical Code and to maintain electrical safety. The National Electrical Code provides detailed requirements for the use of flexible cords and cables. These requirements cover aspects such as conductor size, insulation type, ampacity, and allowable applications. Always refer to the latest edition of the National Electrical Code for the most up-to-date information. When using flexible cords and cables, it is essential to follow certain precautions to prevent electrical hazards. These precautions include: firstly, inspect cords and cables regularly for damage. Check for cracks, cuts, and frayed insulation. Replace damaged cords and cables immediately. Secondly, do not overload cords and cables. Exceeding the ampacity rating of a cord or cable can cause overheating and potentially lead to a fire. Thirdly, avoid running cords and cables under rugs or furniture. This can trap heat and damage the insulation. Fourthly, do not use cords and cables in wet or damp locations unless they are specifically designed for such environments. Exposure to moisture can create a shock hazard. Fifthly, use cords and cables that are appropriate for the application. Ensure that the cord or cable is rated for the voltage, current, and environment in which it will be used. Sixthly, do not modify cords and cables. Avoid cutting, splicing, or taping cords and cables. These modifications can compromise the insulation and create a safety hazard. Seventhly, unplug cords and cables by grasping the plug, not the cord. Pulling on the cord can damage the connection and create a shock hazard. Eighthly, store cords and cables properly. When not in use, store cords and cables in a dry and protected location. Avoid kinking or twisting the cords, as this can damage the conductors. By following these precautions, the risk of electrical hazards associated with flexible cords and cables can be significantly reduced. Proper installation, maintenance, and usage are essential for ensuring electrical safety. In summary, the installation of the transformer above the ceiling tile with the 12 volts alternating current side running through conduit to a junction box appears to comply with Article 400.7 of the National Electrical Code, provided that the transformer is accessible, enclosed, and properly grounded. However, it is imperative to ensure that the transformer is securely supported, the conduit is appropriately sized and installed according to Article 300, a Class 2 power supply is used for the 12 volts alternating current load, and a permit is obtained with an inspection conducted by a qualified electrical inspector. These steps will help ensure compliance with all applicable codes and standards and maintain electrical safety. Article 310 covers conductors for general wiring. Several factors from Article 310 are relevant when considering the 12 volts alternating current side of the transformer. Firstly, conductor size. The conductor size must be sufficient to carry the load current without overheating. The National Electrical Code provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation conditions. Secondly, insulation type. The insulation type must be suitable for the voltage, temperature, and environment in which the conductors will be used. Common insulation types include THHN, THWN, and XHHW. Each type has different characteristics regarding temperature rating, moisture resistance, and chemical resistance. Thirdly, ampacity correction factors. The ampacity of conductors may need to be corrected based on ambient temperature and the number of conductors in a raceway or cable. The National Electrical Code provides tables that specify the correction factors to be applied. Fourthly, voltage drop. The voltage drop in the conductors must be within acceptable limits. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Fifthly, conductor identification. Conductors must be properly identified to indicate their function. The National Electrical Code specifies color codes for identifying conductors, such as black for unbranded conductors, white for grounded conductors, and green for equipment grounding conductors. Sixthly, conductor terminations. Conductors must be properly terminated to ensure a secure and reliable connection. Use approved connectors and terminals that are compatible with the conductor size and material. Seventhly, conductor protection. Conductors must be protected from physical damage. This can be achieved by installing them in conduit, raceway, or cable. Eighthly, conductor splices. Conductor splices must be made in accordance with the National Electrical Code requirements. Use approved splicing methods and materials to ensure a secure and reliable connection. Ninthly, conductor grounding. Conductors must be properly grounded to provide a path for fault current to flow back to the source. The National Electrical Code specifies the requirements for grounding conductors and equipment. 10thly, conductor derating. Conductors may need to be derated if they are installed in close proximity to other heat-generating equipment. The National Electrical Code provides guidelines for derating conductors based on the ambient temperature and the proximity to other heat sources. When selecting and installing conductors, it is important to consider all of these factors to ensure a safe and reliable electrical system. The National Electrical Code provides detailed requirements for conductor selection and installation. Always refer to the latest edition of the National Electrical Code for the most up-to-date information. Proper planning, installation, and maintenance are essential for ensuring a safe and compliant electrical system. Also, you have to maintain proper clearances around electrical equipment for safety and ventilation. The National Electrical Code specifies minimum clearance requirements for electrical equipment to ensure that there is sufficient space for access, maintenance, and ventilation. These clearance requirements vary depending on the type of equipment and the voltage level. It is important to consult the National Electrical Code for specific clearance requirements. Furthermore, you must use appropriate wiring methods for the environment, such as using conduit in damp or corrosive environments to protect the wiring from damage. The National Electrical Code specifies different wiring methods for different environments. For example, in damp or corrosive environments, it may be necessary to use conduit or other protective measures to protect the wiring from damage.